today we're going to solve rational equations. To solve rational equations, you multiply the entire equation by the least common denominator. But if you have a fraction equals a fraction, then you cross multiply to solve. So let me show you a couple examples. Fraction equals fraction, fraction equals fraction, fraction equals fraction. And again, but look, fraction minus fraction equals, and you could call that a fraction because you could say that's 6/1. Fraction plus fraction equals fraction. So when I look at these 1 through 4 have a fraction equal to a fraction, I can cross multiply and solve these, and that's what we're going to do. Now what I did is I have put the answers here. So I think I will solve the first one, and then I will take the second one and the third one, and when I import it into iMovie, I will speed it up so that you can watch me solve it, but you don't have to watch each of the steps. So to cross multiply literally means to do 2 times 2x minus 7 equals 5 times x plus 8. Then you're going to distribute. Subtract 4x, subtract 40. Is that negative 54? Negative 54 equals x. And I did get the correct answer. X equals negative 54. You could also substitute it in. Negative 54 plus 8 is what? Negative 44. So 2 over negative 44 would be negative 1 over 22. And then you'd have, that's probably not going to work, is it? Then you'd have, I'm going to get rid of all that. I'll make sure to. In case I'm not quite sure how this speeding up things works. Probably going to speed up my voice as well. So I'm going to try to speak clearly and concisely, and then I'll probably sound like a character that has a really high-pitched voice. So I'm going to cross multiply. X times x equals negative 4 times x plus 1. Notice when we did the first one, we got a linear equation, but this time I got a quadratic equation. So now I'm going to add 4x and add 4. So x squared plus 4x plus 4 equals 0. Can I factor this? Can I find factors of a times c that will give me a sum of b? Yes, 2 times 2. So x plus 2 times x plus 2 equals 0. Hopefully you notice this is called a double root. I do not have to solve that twice. I am recognizing that I have a double root. So x is going to equal negative 2. Okay, and that's where negative 2 came from. Now let's look at the next one. I'm going to cross multiply. I'm hoping that the next one will give me the opportunity to explain to you something about solutions that are excluded. Or if you noticed when you were checking your assignment for adding and subtracting and maybe even multiplying and dividing rational expressions, you had that x cannot equal something. So hopefully, I'm hoping this one will give me that opportunity. So I'm going to multiply on both sides. I think that's minus 5x. Minus 6 plus 1, and then minus 6. And that will be x squared plus 2x. So minus x minus 6. And it's not going to give me that opportunity, but I will have that opportunity soon. Subtract x squared, so my quadratics are gone. I am going to add 5x and add 6. So I'm going to have 0 equals x. X equals 0 is the solution. That's what it says up here. Okay, going on to number 4. Cross multiply. Maybe this one will give me that opportunity, but no, I see 2 solutions. I will encounter that opportunity somewhere close by. Okay, distribute negative 2, so negative 2x minus 42 equals x squared plus 6x minus 27. I'm going to add 2x to both sides and add 42. So if I add 2x to 6x, that gives me positive 8x. If I add 42 to 27, is that 15? Yes. A times C, sum of B. Yes. Then I will do the zero product property, set each factor equal to 0, and solve. There's one solution. Oops, subtract 5. So those are my solutions, and it says it up there. So I was correct on that one. We'll slow it back down for a moment with the next couple of examples, and then I'll speed it back up again. So now I don't have a fraction equals a fraction, so I can't cross multiply. I'm going to have to find the least common denominator like we did when we were adding and subtracting fractions. Remember, 6 has a denominator of 1. So when I look, I always like to compare my expressions that have variables and then compare my constants. When I look at these two denominators, my common denominator would be 7. So that's going to be part of my least common denominator. And then there's no other variable in this problem, so x has to be included in my least common denominator. Now what I'm going to do is I am going to multiply everything by the least common denominator. I'm going to multiply the left side by the least common denominator and the right side by the least common denominator. Okay, so I'm going to distribute the 7x here. 7x times 4 over 7 is going to be 28x over 7, which is 4x. 7x times negative 1 over x is going to be negative 7x over x, which is going to be negative 7. And then 6 times 7x is 42x. Next, we will subtract 4x from both sides and divide by 38. And I do believe if you look up there, the answer is negative 7/38. Yep, that's what I was supposed to get. Okay, let's try the next one. As I look at that, I need to decide what my least common denominator is. I have a binomial x plus 1, I have a binomial x plus 2, and a binomial x plus 2. So right now, as far as binomials are concerned, I have these in common. So x plus 2 is part of my least common denominator, and then I need to include x plus 1. So that is my least common denominator. Now I'm going to multiply both sides by the least common denominator. X plus 1 times x plus 2. It does not matter the order that you put those in. I'm not going to have very much space, but I'll try my best. And I'll do the same thing on this side and multiply by the least common denominator. Now, I will probably skip this next step when I do the next problem, but I want to show you what happens when I multiply these two binomials times this fraction. Then I get 3 times the quantities x plus 1, x plus 2, divided by the quantity x plus 1. And then I get 4 times the quantities x plus 1, x plus 2, and divide it by the quantity x plus 2. Then for the last one, I'll get 15 times the quantity. I'm going to put a piece of paper over and write on this. 15 times the quantity x plus 1 times x plus 2. Now, all of those fractions can reduce. I can reduce this away, I can reduce this away, and I can reduce this away. So I'm left with 3 times the quantity x plus 2 plus 4 times the quantity x plus 1 equals 15 times the quantity x plus 1. And now we're left with something familiar that you know how to solve. So we'll distribute those numbers to each of those terms. Combine like terms on the left. I'm going to subtract 15 and subtract 7x. That leaves me 8x on the right and negative 5 on the left. So x is going to equal negative 5/8. And that's what it says up here that I should get for the answer. So that is correct. Moving on to number 7. And see, look, I still have a fraction minus a fraction equals a fraction. So I can't cross multiply. When I look at number 7, I need to look at this binomial and this binomial. And this binomial looks close to this binomial. You need to make sure to factor your denominators if you can, so that then you can look for your least common denominator. So as I look at this, I've got a binomial x plus 4 and a binomial x plus 4. That's part of my least common denominator. Then I have a monomial x and a monomial x. That also is part of my least common denominator. So now I'm going to multiply both sides by the least common denominator. X times x plus 4 is going to be multiplied by 12 over x plus 4. I need a parenthesis there. Minus 7 over x. And then 22 over x times x plus 4 is going to be multiplied by x times x plus 4. Now, like I said on the last problem, I'm not going to write that exactly out the way I did with number 6. I want you to look at these two terms being multiplied, and you're going to multiply them with this fraction. Can you reduce? Yes. You can get rid of the x plus 4s, and you're left with x times 12. So we can go straight to 12x minus, when I multiply or distribute this to this fraction, can I reduce anything? Yes, the x's will go away. So I'm left with minus 7 times the quantity x plus 4. Put my equal sign. Now look at this fraction and multiply it by the least common denominator. Can I reduce anything away? Yes, they are exactly the same. This denominator and this least common denominator is the same, so I can reduce that away and I get 22. Now let's distribute. 12x minus 7x minus 28 equals 22. 12x minus 7x, I'm going to combine those. That's 5x minus 28 equals 22. 222. I'm going to add 28 to both sides. So 5x equals 50. And divide by 5. I do get x equals 10, which is what I was supposed to get as the solution. Okay, let's move on to number 8.